OpenAI just released their Agents SDK, a simple but robust framework that can make building, maintaining, and tracking agents very easy. In this video, we will learn all about the Agents SDK. We will build 3 levels of apps, each with increasing feature set and complexity. And by the end of building level 3, you will have your very own deep research agent that can do a lot of heavy lifting, and you can tweak the levels of sources you want to gather. Let's get building. For our 3 levels of apps, for the first level, we'll build an intelligent chatbot that's able to route your answers through different agents. For level 2, we'll add some robust guardrails to it. And for level 3, we'll try to replicate OpenAI's deep research agent and allow it to scour the web for web searches and also be able to put together the whole report in a nice fashion. Before we get started with building our agents through the Agents SDK, we have to understand the foundational aspect that's enabling the Agents SDK. That is OpenAI's new Responses API. The Responses API is OpenAI's new core API, and it forms a very important part of its Agentic framework. It combines the simplicity of Chat Completions API and uses the features and the feature set from the Assistance API. Now, Responses API is not meant to replace Chat Completions API, but it is the next evolution of Assistance API, which is going to get deprecated over the course of the year. They plan to move all of those features over to the Responses API. How does Responses API differentiate itself from the Chat Completions API? And to see that, let's take a quick look at a differentiation between these two APIs. As you can see, Responses API has additional subset of features like tool use, web search, etc. built into it. Also, the big computer use is also available in the Responses API. Responses API essentially takes the user's input, and based on its instructions and tools that it has access to, it does a bunch of calls before it gives the user the final output. Now, if you had to replicate this in the chat completions, you'd be going back and forth with the LLM. This reduces the LLM back and forths and kind of reduces the latency at which the user is operating at. The Assistance API used to do that. There were some features in the Assistance API that were missing that we're getting from the Responses API. One is the more important computer tool use, but also how it handles the different tools that it has access to. Responses API makes it feel a little more flexible and a lot more forgiving when you're using tools. This is the API that's going to be driving a lot of our Agent SDK. One question that has been brought up since the announcement is, how is history being stored in Responses API? If you remember, in Assistant API, you had the concept of threads, and each assistant can run on the thread. So you had a user, you had a conversation history that was saved, and that could be affected by different tools. But in the Responses API, there is no threads concept yet. They do intend to bring feature parity soon. In Responses API, you can actually get the same level of operation by using what's called the previous response ID. So as long as you mention the previous response ID in there, which is the previous output of the Responses API, you will maintain that conversation history. Users have reported that as long as you use the previous response ID, it puts together a chain of IDs and it keeps all of the history together. Now that we've learned how Responses API works, we'll go into a little more detail on that subject in a different video. Let's get into looking at Agents SDK. The Agents SDK. Before we dive into coding, let's understand what the Agents SDK was and why OpenAI created it. The Agents SDK is a Python framework developed by OpenAI to simplify sophisticated agent-based applications. It actually tackles a problem that most developers face: how to build applications where you can allow the large language model to in itself reason, plan, and take actions. At the end of the day, that is the description of an agent. Now, allowing this interaction between different roles, etc., and so on and so forth, there have been a lot of tools out there. N8N and other agentic kind of frameworks have been brought to fore. But OpenAI's version of how they are trying to tackle this is a little more code oriented. What OpenAI does is it gives you a set of primitives that you can use to build your agent framework. The primitives are basically these. You have models, you have tools, you have knowledge and memory, you have guardrails, and you have orchestration. At the end of the day, these are the 5 most important parts of any agent framework that you want to build. Let's talk about what is an agent. An agent, as OpenAI describes it, is a language model equipped with a specific set of instructions and tools. Think of an AI assistant with specialized capabilities and knowledge about how to use them. Let's take a look at what the basic building blocks of an agent is. An agent has a name, an agent has some instructions, an agent has some tools that it can call on to accomplish its task, and we'll take a look at this in a little later, an agent also has a handoff description, just for another agent to understand when it can hand off a task to this agent. Once you have your agent, you need to be able to run these agents. And in Agents SDK, the running is determined by what's called a runner script. Runner script is nothing but an Agents SDK version of an agent loop. The runners command quite simply creates a loop for our agent to function in. When you have a question and you provide it to the runner script, it uses that question and determines when it can finally finish the output of that question. Now, you can set different ways on how you can check for that, but the LLM does its best way to reason if the output is reached for that user. Let's take a look at this with an example. Let's say a simple example of I'm asking a question. I want 2 different agents, a math tutor agent or a history tutor agent, to be able to answer my question. We are also creating a third agent, which is called the triage agent, which has another important component there, which is called the handoffs. Handoffs are nothing but a decision point that the agent needs to make to give it to some other agent. The third part is the runner part, which I explained as a for loop. So you are asking the agent SDK to run this question and provide it to this agent and run it and provide the result over here. Now, as I said, the Agents SDK will run a couple of different loops before it gets you the output. We'll also take a look at how these loops manifest. So let's run this example and see how the output will come. Now, when I run this, it should send me to the history agent, and the output should also say that the last agent that was run was the history agent. As you can see, it has answered me who George Washington was, and it's also mentioned that the last agent that was run was the history agent. Now, what if I change the question to be a math question, right? What is 1 plus 2? There you have it. It's given us a little bit of a more descriptive way of what it's done, and its last agent that was run was math tutor. Let's take a look at how these manifest back in OpenAI in their trace logs, which is the third part of Agents SDK, where everything is being traced. As you can see, the recent runs I've done were the history tutor and the math tutor. Tracing works based on the flow of that runner script that we ran. So in our runner script, we first sent it to the triage agent. The triage agent then did the handoff to the history tutor. The history tutor then took that and provided a response, right? So you can then track your flow of your runners based on this aspect. This allows users to understand the flow of their code and how the agents are running, and more importantly, to see the details of how long each activity is taking and so on and so forth. Now let's take all of the things we've learned and build a little bit of more complexity to it and build a level 1 app. For our level 1 agent, we're building a Streamlit chat. Let's take a look at how our level 1 app works, and then we'll get deeper into the details. For our level 1 app, we are essentially creating a chat interface. We're going to ask a question. The triage agent is going to take the question and hand it over to one of these experts that we've created that basically can answer these questions. What I've done is I've also given each of these experts some tools, which are either function calls that I made in my own code or given them access to do web search if they want to. Let's get down to seeing how this works. So for my first question, I want to ask it, what is the weather? It needs to understand that that needs to go to my travel advisor, and that gives me the weather because I equipped that with the weather tool. I can also ask it, can you plan a 2-day trip there starting tomorrow? Let's kind of ask it a question that will take it to the math. That goes to the math tutor. Let's take a look at how these are manifesting in the trace logs. As you can see, the manifestation of these, they go to the triage agent. It goes to each of these specialized agents. And you can see that it's doing a couple of calls to different functions as well. So that's where the beauty of Agents SDK comes in, where you can equip each of your agents with whatever tools, functions that you want, and it can understand and do a good job of calling them appropriately. This is what the Assistance API did really well, and I think they're trying to replicate with the Agents SDK. Again, going back to our math question, you can see that it's going to the math tutor. Let's take a look at the code. It is a little bit more complicated than how we had built our basic agents. Here, what we're doing is we're adding some obvious Streamlit functionalities for chatting. But the more important part is we are here creating our specialized agents, which are our math tutor, the general information assistant, creative agent, and the travel advisor. Again, important aspects to learn here is seeing the handoff description, because the triage agent needs to know what the handoff description needs to be, and also looking at the tools that they are equipped with. So if you can see here, the travel advisor, I've equipped it with a web search tool, which allows it to do web searches, etc. If you go to the triage agent, essentially you can see that it's using specialized agents as its handoffs. Again, all of this is declared and available for the triage agent to call upon as it needs. Other than that, the rest of the Streamlit app is a very simple chat app. Now, to build a level 2 app, we're going to add a little bit of robustness into our Streamlit app. Now, remember, when these agent loops run, it can become an expensive affair, because once the agent loop runs, it's going to find handoffs, etc., and so on and so forth. So it will consume tokens and calls, etc. But one of the ways to kind of reduce and be careful not to waste and to keep the thing a little more robust is to add guardrails to your agent. Now, let's talk about guardrails in a simplistic term. Guardrails are essentially checkpoints that you can create before an agent runs or after an agent runs to either pre-stop an agent from running or after the agent runs to check the quality of the output. This is important because when you build your for loops in your code, you get to make all of those conditions. But here, when you run the runner, you don't actually set those expectations. So you expect the LLM to make those choices for you. So guardrails is your way of introducing these conditions that will make the output a lot more qualitative, and that will make the run only necessary. Guardrails can be of two types. There are input guardrails and output guardrails. Input guardrails, like I explained, is to nip the agent run in the bud, where you don't actually run the agent if the user asks a very bad query, something that's irrelevant. And the output is to control the quality of the output. Same example that we did in the first part, where we created those math tutor, history tutor, and we did the triage agent. We're adding guardrails to it. What we're doing here is, in addition to our agent runner classes, we're also importing input guardrail and guardrail function out. Essentially, what we're trying to do is, if a user asks a question, we're trying to determine if it's part of homework or not. If it's not homework, we don't want to even let the triage agent send it to the handoff agents. What you'll add here in the triage agent is you'll add an input guardrail. You'll add an input guardrail and you'll give a guardrail function here. You can also be very specific and explicitly state it. So homework guardrail is the function. The homework guardrail runs a guardrail agent. So you can also build agents that act as guardrail agents. The guardrail agent that you built is a homework guardrail. The agent there has a very specific instruction. Check if the user is asking about homework. If the user is asking about homework, then output homework type. If the user is asking about homework, you can also set a structured output type to any agent. And in this case, we're setting a structured output of homework output, which essentially is a class where we're declaring if it's a Boolean operator and any reasoning that we are going with. That is being sent as your output to your runner for your guardrail agent. Guardrail agent takes a look, and if it's not homework, it kicks it out. Let's ask this question now to the triage agent. What is life? Now the flow should be triage agent goes here. It goes to the triage agent. It checks the input guardrail, which is also an agent. So it goes to the guardrail agent. It determines if it's a homework, yes or no. If it is a homework, yes or no. If it's not a homework, you essentially tripwire. You essentially stop the process where it is. And if it is homework, then you go to the next step. Run this and see how this works. So that triggered a tripwire. Now let's see in the trace logs how this is manifesting. As you can see in the trace logs, when it went to the homework, it did the guardrail check and it tripped. So it didn't even go to the actual handoffs, right? Let's take the same program and run it with an actual more legit question, right? In this case, let's ask the same question about who was the first president of the United States. And let's comment these out and let's run the same command. Now we expect the guardrail agent to pass this command and it will now give us the output. So if you go back to the trace logs, you can actually see that the guardrail check is positive, and then it goes to the handoff, and then the handoff sends it to the history tutor, and then history tutor gives you the output. Let's quickly jump how we can take this and make it a little more complex for our level 2 app. Let's take a look at how our level 2 app runs. Level 2 app is the same exact level 1 app, but I've added guardrails in action. So what if I am going to ask it, the triage agent trips there, right? So let's take a quick look at how our guardrails are manifesting. Input validator says it's not possible. Let's take a look at the code. The code is, again, you've established your agents that you have, your specialized agents, you've established your specialized agents, etc. You are adding input-output guardrails. So let's take a look at some of the input-output guardrails. You are adding input-output guardrails. You are adding some input-output guardrails of what you should allow, what you should not. And that kind of gives you some information about. You're adding some input-output guardrails. And that is the only difference between this and the level 1 app. Now we've seen how this works with single time triage agent sending it to one agent or the other, right? In our level 3 app, we're going to take it a little further. What we're going to do is we're going to take an app and run multiple agents where the loop is continuing till you get the end result. And we're trying to mimic the exact clone of how deep research works. How does deep research work? You ask a question, it goes, scours the web for some web results, it puts them all together, and then with its very high capable model, writes a report for you, right? So we're trying to do and replicate that. Let's take a look at how our level 3 app runs. For our level 3, we are validating our API key. We can restrict the amount of searches that we want to add. The more searches you add, the more detailed and complex the answers will be. In this case, for this example demo, I'm restricting it to 3. And I'm going to ask for essentially it to do these aspects. You go to the planner agent, create a bunch of search queries for your question that you've asked, go to the search agent, make the searches, and then go to the writer agent that writes the research report. So, for example, in our case, if we want to say the effect of AI on healthcare, it's going to do the planning searches. And then it's generated 3 to 4 search terms. So it's going to do AI search impact on healthcare industry, AI applications in healthcare, and it's going to go benefits and challenges of AI in healthcare. If you went more to it, it would generate more complex topics to search. So basically, your deeper your web searches are, the more the web searches are, the more deeper it gets. So now it's generating this report. You can also pick your report writer model. Right now, I'm just setting it to GPT 4.0 and 3.5. But if you really want a high performing model, something like 4.5 or 3 should give you higher level of like how you're writing your research. So this research summary is also restricted to a certain number of words. You can update it in the Streamlit code, and I'll show you where you can update in the Streamlit code to get more detailed. This is your full report. And it gives you, that was a summary, and this is the full report. It kind of talks about the different things that are there in the healthcare. It gives you with the links, etc. You can go see what the searches were also, like the different searches, what they were. And also at the end, you can see some follow-up questions you can ask if you wanted to kind of go more further and deeper, right? You can also see the flow of steps. Let's look at the trace log for this. The trace log for this is this way. The research planning agent went first, then you did web searches, and then the report writing. Here, I'm actually not including this in a runner because I wanted to show you a couple of different ones. In our previous ones, we've actually seen the LLM make the call to go to the different ones. Here, you're actually doing it a little different where you are using your code to do the coordination. Now, an important aspect of why I wanted to show this was in either cases, you get good results, but a good app is always a mix of code-based orchestration and LLM-based orchestration. Here, even though I did it code-based orchestration, I was able to look into the details of what was given at each step, and I was able to collate it in a very organized manner. Let's take a quick look at the code, and then we'll kind of talk about a little bit more details here. So for level 3 agent, as you can see, we're setting up these different agents, each of them are coordinated through the code. It understands and generates that output. And like I said, you can get a little more complicated you can get very complicated with the report writer by increasing the number of words, etc. Now let's take a look at how I can do this same example, but with a runner instead. As you can see, I am taking the Streamlit app is running exactly the way it ran the first time around, but the difference would be how we look at it in the trace logs. In the trace logs, you could see that the runner is actually controlling the flow of activities. And like I said, you can choose the way you want to coordinate your agents. The important part is to understand how you are kind of fashioning this. The important thing to understand is a good app is always a mix of both. Don't always rely on LLM or don't always rely on code. All right, and that about sums up our 3 levels of apps that we've built. Whatever we discuss in this call, I will link all of them to the repo that I'll share in the description below. I've also kept a couple of cheat sheets that would be really useful to understand these concepts. One is a cheat sheet for all the commands for the Agent SDK, and then the other one is a one-pager that is a little bit of an abridged version of it. All right, so where does this take us? Like, what's the real world impact of an Agents SDK? It allows developers to create complex systems with very minimal lift and shift. You don't have to create the code that would be doing the coordination pieces, and it gives you a server side tracing capability that you can kind of trace and view the results of. It also gives developers, as someone who's developed an assistance API based app before, it allows developers to let the user have a single conversation thread that you can use different tools to. What this brings us to is a very important topic of agents itself. You've seen here most of the agents were actually created with instructions and using the models from OpenAI. But the goal of agents is to take it one level further. You will face a There will be a time in the next few months where we'll have specialized models that are very good for certain tasks. For example, let's say you're developing a healthcare app and you wanted to ask a health-based question. You may not want to hit OpenAI, but you may want to hit Google's Med API, Google's Med LLM for those questions. So when you are tackling these questions with specialized agents that are domain specific experts, you want a framework that's capable of handling that. And Agents SDK allows you to do that. I can't wait for all the awesome things that people will build. If this video has helped you learn Agents SDK, feel free to subscribe. I will be dropping another video about Responses API and how to use that in a short time. Thank you so much. Enjoy building.